I request everyone to please attempt all the quizzes which we have floated. So there are around 12 quizzes, right? And we'll not be giving more quizzes now onwards. So these 12 quizzes will be used to uh, like decide who among you are getting the final certificate. These are very easy quizzes and that is required for our file purpose. So we are not trying to test you. We know that uh, you all are expert in your area. So the idea is not to test you, but to for our record, we need that. So kindly go ahead and you can always discuss in case you have any doubt and you feel that some questions are not right or there's some error. So you can always uh, come back to us and we'll take necessary action. So thank you so much. So shall we start next session?
Yes, sir.
Okay. And kindly keep interactive because that makes us like that. Yes, you are listening to. Okay.
Hello, sir.
Yeah.
Yeah, you have provided the list of quizzes, and there is a line that out of 6 and 7 quiz that is
Yeah.
based
One.
on part 2 to 4. So I have attempted one, so it is sufficient, na? There is no
It is
need to.
sufficient.
Okay, sir.
Yeah, it
Thank
is
you.
sufficient. Actually, that same quiz was posted twice.
Yes,
So
yes.
people have attempted either 6 or 7. So we are keeping both so that we can take best of the two. No issue on that.
Okay. So if anyone is also fine.
Fine. Fine for
Thank
us.
you.
Yeah.
Okay, sir.
So in total, there are 11, in fact, in that sense.
Yes, yes. Okay.
Is my slide visible to all of you?
Yes, sir.
Okay. So I think it's so good morning again. So now this session is about network slicing in 5G. Particularly, I'm talking about what standards, what 3GPP standard talk about and what ITU talk about network slicing. So the session is based on a standard by ITU and 3GPP. Okay. So let us introduce network slicing. I think all of you already know it, but let's repeat it for sake of our knowledge. So what is a network slicing? So network slicing is creating multiple logical network over the same physical infrastructure. As we know that in 5G, we are able to deploy network function on a virtualized infrastructure, on a cloud infrastructure, so that can be logically divided into different slices for different services. And then every slice, whatever number of slice you create, every slice can have different quality of service requirement and it will serve a specific service as we had seen during our 5G core and other introduction sessions that I can have multiple number of slices. One slice maybe for a smartphone, other slice maybe for massive machine type. The slice can be for say smart meter and so on. So there can be many number of slices in a network, in a 5G network. And when we say network slicing, in fact, 3GPP is talking about creating end-to-end network slice, which will include our radio access network, then the backhaul connecting RAN to the core, and also the core, and also finally the application. So for every applications or collection of some application, we can have a slice. And finally, slices are logically separated in a way that they will not affect each other. Rather, they are secured individually. That means any security breach in one slice will not affect other slice per se. May I request all of you to kindly keep your mic in mute for everyone interest. Thank you. Okay. So what I was talking about is like we have a radio access network consisting of G node B or new radio, and then we have 5G core consisting of multiple network function. We had talked about AMF, SMF, UDM, NSSF, NRF, NEF. So 5G core would consist of multiple instances of each of these network function, and these can be virtually divided into slice. So in this example, suppose we have slice for say autonomous car, we will call it V2X network slice, and then it will connect to a data network which is V2X service. So every service will have its own server, and that will be part of the slice. The other example can be a slice for smartphone. That means use of this particular slice for we human, and then it will connect to a smartphone service. In our case, if it is say a voice call, then it will connect to the IMS system in the 5G network. And then finally, it may be a smart meter network slice, and it will connect to the server related to smart meter. So there can be n number of slices. There is no limit defined that how many slices I can create, end-to-end slices I can create, right? And as I said, every slice will have its own quality of service. Like, for example, a smart meter slice would not require very high speed or very sensitive latency requirement, but the coverage requirement would be important. Connectivity requirement would be important. Similarly, for V2X slice, latency is a very, very important requirement. And for a smartphone, we require speed, we require good spectral efficiency, and we also require to some extent the latency. So when you divide our network, I'm talking about initially about the core part. The core part, when we divide, this picture is from 3GPP. When we divide in a logical partition, how we divide, let's see. So in this example, there are three slice zones, slice 1, slice 2, and slice 3. So as you can see that there are some network function which is common to all the three slices. Can you see which network function is common to all the three slices? Can you just see and tell me?
NRF
Yes,
and NSSF.
NRF.
very right. So the network repository function, which is the function of NRF, as you know that it has addresses of all other network function. So NRF is common to all the three slices, and network slice selection function. So this is the entity network function which tells the AMF that which network slice is to be connected for an user equipment. So these two are common to all the three slices. Now, if you see slice 1 and slice 2, in case of slice 1 and slice 2, there are certain network element which is common to these two slices. Now, can you now also speak the name of these network function which are common to slice 1 and slice 2?
SMF, UPF, and PCF.
Correct. So this is PCF, NRF, and AMF. These three network function are common to the two network slices. So in this case, as you can see that there is another NRF which is for specific to these two slices. So in a network 5G core network, you can have multiple instances of NRS. One is a common NRF for all the slices, other may be for one or two specific slices. And then policy control function and AMF can also be common to one or more than one slices. Now, if you look at third slice, so it has got its own AMF, NRF, all network function of slice 3 is independent except NSSF and NRF. right? And then they connect to different data network. Data network can be those services, maybe V2X service, maybe smart meter service, and so on. We will go into slightly detail about it in the later half. Okay, so how this network slicing has evolved. So let's go back that how we started talking about network slicing for 5G and how it got evolved. And first of all, we'll see the ITU framework for network slice. So in the ITU, how they have uh, conceived network slicing concept. So this is the document. Just see that this was released in December 2018, and this document is Y.3112. I would request all of you to uh, download and go through. It's a small document and readable document. So this is framework for the support of network slicing in the IMT 2020 network. IMT 2020 is the name given by ITU for 5G. So what it says that, so the first time this concept was discussed in ITU, that IMT 2020 network can be divided into logically multiple slices. And for example, they have shown EMBB slice, MMTC slice, and URLLC slice. And for every slice, you have a data network. For example, EMBB slice may be connected to voice or AR/VR or internet kind of a data network. Then MMTC may be connected to logistics, agriculture, or different IoT kind of servers or data network. And URLLC may be connected to, say, automobile factory. Automobile factory means autonomous car or uh, car related services can be uh, taken care of. So they had talked about network slicing in this manner. Now they are talking about that there can be network function specific to a slice. For example, if I have a EMBB slice, then there will be certain network function like AMF, SMF inside the network slice. Similarly, for the second slice of URLLC, you have a separate AMF, SMF, and PCF. It's just an example. But there'll be some network slices which are UV level. That means one user equipment may be connecting to multiple slices, and there will be certain network function which is common to the U, as we seen earlier that NSSF and NRF was the UV level network function, and in some cases AMF can also be a UV level network function. That means common to more than one slices. So this concept was also discussed in this framework document of ITU. They had also talked about like uh, example that in case I have three slices, EMBB, MMTC, and URLLC. So a single user, for example, this car is an user equipment, will be able to connect more than one slices. So it is connecting to EMBB slices, maybe for infotainment, and URLLC slice, as you can see here, maybe for autonomous driving. Okay, so one user equipment can connect to more than one slices was discussed in the ITU framework document. Okay, other example which was discussed in that particular framework document, that suppose you have different slices. For example, I have two slices for URLLC, A and B. So A is for, say, one company. Let us assume that for Honda automobile company, and second maybe for Suzuki uh, or any other company. Okay. So basically, every automobile company have a different slice into the 5G network, and they have their own server where I mean, these car IoT devices are being serviced or being connected. So in this example, what is shown is that this car maybe belong to Suzuki is connecting to slice URLLC slice B and being connected to their server. In addition, it is also being connected to a common slice of EMBB to support voice services, internet, AR/VR, etc. inside the car. Similar is the case of the second car. Second car is connecting to URLC slice A and also to the EMBB. So this is the example given in the ITU document. Okay, so with this framework defined in the ITU document, now how it evolved within the 3GPP, because as we know that 5G standards are being developed by 3GPP. So how network slicing concept evolved within the 3GPP? So they started with release 14 itself. As we know that release 14 was some sort of precursor to 5G release that happened in release 15. So release 14 itself, they started discussing about these aspects. So what should be the operational requirement? What should be the service requirement for a network slicing? This is what was discussed in this particular document. This is called TR 22.891. So this document, basically they are talking about feasibility study on new services and market technology enablers. And here they are talking about slicing also. They are talking about many things, but slicing is our concept of slicings are also discussed here. So if you look at this, this gives two requirements, service requirement and operational requirement. Let's see these, what they are talking about. So in respect of service requirement of network slicing, they are saying that uh, we should design the 5G network in a way that operators are able to compose network slices. So that means over a certain standard way or maybe a certain configuration enabling, operators would be able to create a network slice in a very, very easy way. Then slice should be created in a dynamic way. It's not that uh, all the templates are static and only the static parameters I am able to create a network slice. I should be able to create in a dynamic way. That means I can myself decide that what this slice should support, what kind of quality of service it should support dynamically, right? And then there should be ability that which user equipment will be able to connect to a particular slice. So the network should be able to identify certain terminals or user equipment or subscriber who can associate with this particular network slice. For example, if I have subscribed to AR/VR service, so I'll be allowed to connect to a slice which supports AR/VR service. Similarly, a autonomous car should be able to connect to the slice of autonomous car. So that capability should be inside the network. And network should enable the user equipment so that it is able to take service from the particular network slice. So these things should be possible. That's what they talked about in respect to the service requirement. Other is the operational requirement. One is from the service provisioning point of view. Other is from the operational point of view. So operational point of view, operators should be able to create and manage network slices. And these network slices should be able to operate in parallel. I should be able to operate in parallel. That means multiple number of slices would be ongoing and there should be isolation between different slices. I should be able to have a clear isolation the way I slice them. The other operational requirement is that the security requirement. So every single slice, I should be able to define a specific security, right? So the level of security in different slices, I should be able to put it in a different way as per the requirements. That's the capability we are talking about. And then the slices should be,
सब्जी काट दो फिर करियो भांडे
I think there is a noise coming. Let me mute. I think there is a raise hand by Srinivas ji. Do you have any question?
No, sir. It is a previous session.
Okay, then you can lower it. So thank you.
Thank you, sir.
Okay, let me continue. Okay, so we had talked about these. So that means suppose there are multiple slices and there is a cyber attack on one slice. So it should not impact other slices, right? Isolation should also be in respect of the network security. Then there should be a capability wherein operator are able to authorize third parties to manage a particular slice. For example, what does this mean is that suppose one slice is created for, say, Maruti Suzuki or Honda. So Maruti Suzuki or Honda should be given certain rights onto those slices that they are able to manage it, right? Or even a new network slice creation should be possible in case an operator authorize a third party. And these slices should be elastic. That means when there is a growth of traffic, the resources allocated to different network functions should also be increased in a way that it is able to handle the traffic. So, and this elasticity should not impact services on other slices. That means it should take the compute or memory or whatever is required from whatever is the balance in the virtualized infrastructure, not still from other network function. And there should be a capability where I should be able to change the slice parameters, right? In a way that it should not affect the customers or subscriber who are being served at that point of time. Suppose, for example, if I decide to change certain quality of service parameter, and if some users are already using a quality of service which I'm trying to remove now, so those subscribers should not be affected. I mean, the effect of the new configuration should take once all calls are terminated. And finally, the slices should be end-to-end. So these were operational requirement as talked about by 3GPP, particular document which I shown. So with this, let's look at how network slices concept was evolved in various releases of 3GPP starting from release 15. As we know that release 15 was the first 5G release. So in the first 5G release itself, the basic network slicing standards came out. So foundation of network slicing came during release 15, which was released around 2019, 18-19. So that means we have concept of slicing from the release 15 itself. And it kept evolving in further releases. Release 16, which happened in 2020. So they enhanced certain features in the network slices, and also they brought it a concept where slice level authentication was added. So generally, a user equipment gets authenticated while you switch on or try to use the data. But now there is another concept that in a particular slice, I can have second level of authentication at slice level. So that has become possible in release 16. And then in release 17, which came in 2022, they added certain more enhancement. And here they have defined the concept of RAN slicing. How the RAN component would be sliced for different slices. And then they have also talked about admission control in release 17. I remember that while I was going through PDU session, somebody asked that how many PDU session can be created. So as such, there was no limit given up to release 16. But in case of release 17, and that too for network slicing, admission control based on number of user equipment and number of PDU sessions are now defined. PDU sessions in terms of number of UE in a slice. Admission control is defined. Admission control is like if resources are full, say suppose number of defined PDU sessions are already created in the network or in a slice, no more PDU session will be created. So that's kind of a admission control concept is there in 5G. Okay, any question so far before I proceed? Or maybe you can tell that I should go ahead. Any question or should I go ahead?
Go ahead.
Go ahead, sir.
One query.
Yeah.
You said that Sumo or Hyundai, those companies are having separate network slice management, but they, of course, they can do as per their requirement, but they don't require any permission. I mean, if they add something which may be harmful to other slice, or how this check is carried out, or there are certain set of protocols that they will never go beyond the capacity.
Yes. So that's a kind of a that was some sort of kind of a 3GPP thought that kind of a enabling should be there, right? And ITU thought in their papers. So it is the trust kind of, it is a trust between an OEM and if suppose Geo is trying to create a slice for say Hyundai or say Suzuki, so they may give certain aspects to manage. They may not give every parameter to be managed by them, right? So depending upon the trust and the requirement, that is one. Secondly, one slice, any change in one slice will not affect other slice. This is also a requirement of 3GPP. So even if something goes wrong in one slice because of whatever reason, maybe because of cyber attack, maybe because of configuration, maybe because of somebody did some mistake, it will not affect all other slices. So that is already taken care of.
Okay, sir. Thank you.
Thank you. Thank you. Okay, so let me repeat the concept of video session. Yeah.
Sir, how network slicing applicable on RAN components?
So that I'll be covering because in release 17, RAN slicing concept came. So how it is being managed, I have few slides on that. So please be patient. I'll be covering that.
Sir.
Right. Thank you. Okay, so let me repeat the concept of 5G architecture, PDU session and QoS quickly for the benefit of all. So as we know that in a 5G architecture, service-based architecture, we have segregated user plane and control plane completely. And in the user plane, the PDU session gets created. When I say PDU session, it handles the user traffic in the sense that if you are accessing internet or YouTube, so your data flows through PDU session, and PDU session is nothing but connection between UE to RAN to UPF until the data network. So it's a kind of a end-to-end pipe which you have through which data flows, and we manage quality of service inside the PDU session. As I had discussed that for the first time when an UV, that may be a car or drone or telephone or anything, connects to the network, a PDU session gets created first. And within PDU session, one default QS flow is added, which is a non-guaranteed type. And later on, depending upon what service it is accessing, more number of QS flows are added inside the PDU session, and every QS flow I can identify can have different requirement in terms of latency, in terms of data speed, in terms of what kind of guaranteed bit rate, what kind of delay it can support, what kind of error it can support, are provided within the QS flow. So with this background, in case I have a network slice, suppose I have a network slice for smart phones. So within the network slice also, I can have one or two quality of service flow. For example, here two slices are shown. In slice one, I am using two kind of QS, say flow A and flow B. And in slice two, I'm using the only one. So that means within the network slice also, I can have more than one quality of service requirement. I'll be serving more than one type of user. That's possible. So now let's look at which are network function, specific network function, which are supporting network slice concept. So this picture we have seen there are certain new network element added. So if you recall, we had a network function called network. Okay, let me ask you, what is this network function? Do you any one of you remember this? Any one of you?
Network slice selection function.
Yes, so it's a network slice selection function. So it assists AMF in selecting a particular slice for a particular UV. And this came in the release 15 itself. When we say the foundation was laid in release 15 itself, so basically we had an SSF as the specific network function in the core. Now in the release 16, as we saw that what was introduced in release 16, do you remember previous slide? Do you remember what was introduced in release 16?
NSSA
Second level
Authentication, sir.
authentication.
So what was,
Authentication, admission control.
yes. So slice label authentication was introduced, and to support slice label authentication, one new network function was added. What was that? Network slice specific authentication and authorization function. Network slice specific authentication and authorization function. So this was really came in release 16. So now we can authenticate within the slice also, in addition to the initial authentication happens for a user equipment. And then we brought in something in release 17. Do you remember what feature we brought in?
Admission control.
Yes, admission control. Admission control based on number of UV parameter or number of PDU session. PDU sessions were added during the release 17, and this is network slice admission control function. Network slice admission control function. So these are three specific network function which is there in the 5G core architecture till release 17. So we may add certain more feature going forward, but these are the network function which we have as on today. So if a particular network is of release 15, you have a basic network slice function architecture. If you have release 16, then you can do slice specific authentication. And then if you are at release 17, you can also do admission control function. Okay, so let's look at each of these network function, what exactly they do it, right? So this table and picture I have taken from the standard itself. I have just copied it, what you see. So basically what you're seeing is an network slice selection function. So this exposes an API. So using this API, the AMF or other network slice selection function can connect. When I'm saying other, this may be from a visited network. When you are in a roaming, you are being supported by the visited network NSSF that has to actually communicate with home network. And your AMF take help of network slice selection function. So either you can connect on the service-based interface API, or you can connect on a reference point architecture. Both options are provided in the standard. Generally, they will use the API part. So let me erase the ink first before I. This is very important concept. Let's look at. So basically what happens that whenever a UV is connected to the network and uh, trying to sort of ask for a network slice, access to a network slice. So the AMF talks to NSSF. So basically through this service, it takes the information, and this network function tells that whether a particular UV is allowed or not. So that information is coming from NSSF. Similarly, is the visited network NSSF take help of home network NSSF for the same purpose. The other function is like many times what happens that if user equipment, if one UV is suppose trying to access slice number 7, and the AMF which it has connected to do not support that, some other AMF is in charge. So in that case also network slice selection function will inform this AMF that look, this particular slice is being handled by another AMF. So it will give a detail of that AMF. So that means if the current AMF do not serve a requested slide, it asks NSSF for appropriate AMF handling that slice on a per TA basis. Okay. So basically, sorry. I don't know what has happened. Just a moment. Just a moment. Give me a moment. Okay. Okay. So this we have spoken about. Now the next network function I want to talk about is the NSSAAF, Network Slice Specific Authentication and Authorization function. So what services it gives to different elements? So basically it gives services to AMF. And what are those services? Let me explain one by one. So first is that when a UV is trying to access a particular slice, then AMF would connect to the NSSAF and request for slice specific authentication. So this one, it's a request and response that AMF connects to or make a API call to this network function to authenticate the user on a slice level. So that is one. The next two are related to, for example, that at some particular time, this network function may want that the user be re-authenticated, the user equipment be re-authenticated. So this is some sort of notification, So this NSSAAF notifies AMF that look, the UV which is being served in a particular slice need to be re-authenticated. So AMF again initiate the slice specific authentication using this request response, which this NF offers. Sometime it is also possible that authentication is to be revoked. So that also is a notification to AMF by this network function that the authentication has been revoked from this slice for a particular UE. So the UE should not be able to access now. So these are different function of NSS AAF. Any question here or shall I proceed? Okay. So let me, yeah. Okay. Okay. So the same thing in a call flow type of scenario, that basically when registration of an UE is taking place, okay, so it tells the network that whether it supports, so UE also need to support slice specific authentications. There should be certain capability in the UE so that slice specific authentication is supported. And if particular slice requires authentication, slice level authentication, then only those UV can connect which supports slice specific authentication, and also they have subscribed it. Okay. So during registration process itself, UV tells the core what is its capability in respect of slice specific authentication. So basically we call it UV 5G core network capability. Is mobility management. So basically UV tells a lot of its capabilities to the network during the registration process. Slice specific authentication is one. And once that is yes, then slice specific authentication happens. So you have a different authentication server or AAA server for slice specific authentication. And there can be a different authentication mechanism. For example, in a normal 5G network, you have 5G akka, we call it 5G aka. And in case of any slice, it may be a other authentication mechanism like EAP, extensible authentication protocol. So you can have a different authentication mechanism within the 5G network. Okay. Now let me talk about admission control, which came in release 17. So what it does. So as we know that this admission control function, the services provided by this admission control function has to be consumed by AMF because it's an entry point of user equipment, by SMF because PDU session is created by SMF, and PDU session is one of the parameter for admission control, and then network exposure function because there may be a third party services being connected, and the application function. Application function is those services provided by automobile companies or any kind of IoT server. So all these can connect to admission control function either on the API, this API call, or maybe on a reference point architecture defined in the standard. So what are those things? So the admission control will be based on number of UE in a slice. In a slice, we may configure that okay, only 1 million UV can be served simultaneously, right? So whenever this limit is breached, no more UV will be admitted into that particular slice. Okay. So every time a new UE is trying to access this UE, AMF talks to this particular admission control function, and this admission control function keeps track of number of UE and number of video sessions. So it will tell that, okay, whether this UE can be admitted or not. So for example, if you see this service is, it allows enough service consumer, say AMF, to request to perform per slice admission control for number of UV and number of video session, right? And similarly, there is a notification also. This notification is about how many number of UVs are being served in the slice, or how many PDU sessions are already established. So that admission control are carried by AMF. So as I talked about that, this provides service to AMF, SMF, NEF, and any application function. Okay. Any question so far, or shall I proceed?
Yes, sir.
Thank you.
Proceed, sir.
Okay. So now, how to identify a network slice and select the network slice? There has to be some identity involved of the network slices. So a standard has given that. So basically, this is the identity architecture of a network slice. So let me explain it a little bit. So when we say NSAI, we are saying that network slice selection assistance information. So whenever we say this, actually we are talking about list of slices. So this is a plural, not a singular one. This is a plural. That means it says that it is a list of slices. When we add S before this, then it becomes single network slice selection assistance information. So then we talk about a specific slice. Specific slice. This is important to understand future slides. So here we are talking about a single slice. So that's why the name given is S-NSSAI. So many short forms, long forms. So don't worry. So it has two parts. One, we call it slice type or service type. 8 bits are there for it. And other is the slice differentiator, which has 24 bit. Okay, let me remove the ink before I proceed. Okay. So there are certain standard value of these. So 3GPP specification, if you read, so they have given up till release 17, they have already released 5 type of different slices that they have talked about. So they have given those values, and these standard slices are defined with 8 bits only. You don't require SD. You don't require SD. When there are standard value given by 3GPP, it is represented only with the 8 bits. You don't need this slice differentiation. So when this SD is required, is like when you have two slices of same type. Suppose I have EMBB slice 1 and I have EMBB type slice 2. This may be for, say, enterprise users. This may be for general users. So in that case, I need to differentiate these two slides. So then I'll have 24 bit added to this so that I'm able to differentiate two similar slices. So SD is to differentiate same type of slices for different set of users, as I explained. Okay. So what are those standard value which 3GPP has given? So I said that only 8 bit information is required. So although I have written as a number SST value 1, 2, 3, 4, 5, but this will be represented with 8-bit, all the values. So SST value 1, service type or slice type 1, that means I'm talking about EMBB type of slice. 2 means this is URLLC type slice. 3 means massive IoT slice. 4 means V2X. And 5 means high performance machine type communication. So 5 types of SST values are defined by 3GPP so far. And they have reserved value up to 127 because with 8-bit, I can go up to I can go up to 256, but up to 127, 3GPP would be defining later on. So those are reserved. An operator can also define their own type of slices. So they also have about 128 in numbers. 128 slices can be configured by the operators. So whenever a user equipment is in roaming, so 3GPP has said that they will only be using the standard value of SST. They will only be using the standard value of SST while in roaming, because roaming is something that if I have subscribed to some service, it is to be followed in others. So operators may have different service. So they'll have certain standard service and they'll have certain specific service. So in a roaming, only the standard one would be applicable. Now some more concept. There is something called default and there's something called configured. So as I had explained that when I say network slice selection assistance information, I'm talking about list of slices. List of slices. So there'll be certain default list of slices. There'll be something configured list of slices. So what are those? So when I say configured, so basically UV is provisioned a set of slices which is called configured slices for a PLMN. Okay. And I'm talking about configured one, right? So per PLMN, these configured slices would be there. Suppose a UV is able to work in more than one PLMN, maybe in Geo, maybe in Airtel. Then for each of these PLMN, you have a configured number of slices. So that means the UV has subscribed to these slices. Other is the default one. So default is like if you are in a home network, so there will be certain number of slices which is default for you. So those are default one, right? So basically when you go on roaming, generally the default slices are available to you. Generally, the default configured slices are available to you. And this will have a standard. As I said earlier that while roaming, you'll have a standard slices available only. So the default means the standard type of slices, that is 3GPP defined one. Okay. Right. Now there is a concept of requested and allowed. So there will be UV would be requesting a list of slices during registration, right? And then there is a concept of one is the request, other is what are the slices, list of slices which is allowed to a user equipment. So what is requested one? Requested one is that during registration, the UV is requesting for a set of slices which it will be accessing over a period of its active lifetime. Okay. So basically what happens that during initial request, this is coming. So Z node B would select an AMF which can handle these slices, right? So it should select a particular AMF which can handle these slices, right? So in the initial request, these are used to select a correct AMF. Okay. Now let me remove the ink. Okay, so other is the allowed one. So the allowed one is the one which network knows, in the sense that when you take a subscription for an user equipment, a system knows that which all slices are allowed to this, which all slices are actually subscribed. So one is that you are requesting. So initially I'm trying to uh, select an AMF based on your request. But ultimately, once you have registered onto the network, I also check inside the network whether that slice is allowed or not. And the allowed slices details are passed on to the UV on completion of the registration process. So UV also knows, will have a list of allowed number of slices, list of all the allowed slices. There is also certain concept of rejected slices. Basically, that means in a particular uh, registration area or tracking area, or maybe in the entire network, some slices are rejected for a UV. So those information is also passed on to the UV so that UV is not requesting that slice. So these are different terminology or the concept in 5G. Okay, so any questions so far? With these backgrounds, I think I'll be able to talk about further slides in a better way. You'll be able to understand. Any questions so far?
So just one question. So when we slice the network, so is the bandwidth is also sliced or a slice will get the full bandwidth?
So bandwidth, when we say bandwidth, basically you're talking about radio, right? Radio or the BTS. Suppose a BTS is operating on 100 megahertz channel bandwidth, right? So when you are slicing the RAN, so of course, uh, you need to allocate certain number of frequency resources for certain slice, right? Suppose in an BTS is operating on two different frequency 1 and frequency 2. Maybe I can reserve frequency 2 for some number of slices. Maybe I can reserve frequency 1 for some other slices. And this I can vary in different TA. In one TA, I can use frequency 1 for a particular slice. Same frequency I can reserve for other slice in other area. Suppose I have a factory area, then my configuration will be different, because in factory area, maybe my application is URLLC. So maybe both the frequency I dedicate for URLLC. In a railway station, maybe I can use both the frequency for normal EMBB kind of a slice. Understood?
Yes, sir. Yes. Thank you, sir.
So I'll be explaining that. And that's what is the concept of RAN slicing, which came in release 17.
Okay, sir.
Okay.
So I have a
Yeah,
question. Can I
please.
say,
Huh.
sir, loud and SSA, can we say it is a default network slice allocate to UE?
Okay. So what is allowed is the one which I have subscribed. Okay. So whenever suppose I take a connection, so I would subscribe to certain number of slices, and based on that, I'll be paying to those operators as UE. Okay. So those slices are accessible to me. Those slices are as a UE accessible to me. So those are allowed one. What was your other question? Is your question answered, or you have supplementary question on it? I cannot hear you. Okay, shall I proceed? Is my voice audible to everyone?
Yes, sir. It's audible, sir.
Yes, sir.
Kindly
Yes, sir.
proceed.
Okay. So inside a slice, how the network function can be there. This we had discussed in the first initial slides that. So this is a different diagram which I tried to make. So I have, say, radio access network, then I have a core, and then I have a data network. So few concept, as we had discussed earlier, that few network functions like NSSF and NRF are common to multiple network slice. In this picture, slice 1, slice 2, and slice 3. There are certain network elements which are common to two slice. Here, slice 1 and slice 2 is sharing PCF, NRF, and AMF. And there is a third slice where I have all the network function separate for this slice, but I have NSSF and NRF outside. I mean, common to the three slices. So the one concept which I wanted to tell you is like, suppose a user equipment is trying to access slice 1 and slice 2, right? So in this case, it is defined that the same AMF has to give service from both the slices. So AMF has to be common when a user equipment is trying to access more than one slices. And so at that point of time, when UV is accessing slice 1 and slice 2, it cannot access slice 3 because for slice 3, AMF is different. So please remember that a user equipment can access to only those slices simultaneously. For it, the AMF is same. Same AMF is handling both the slices. So that's why we will talk about grouping of the slices and uh, accessing to those slices on a group basis later on. Okay. The other let me remove the ink first before I tell you about some more concept. So here you can see that one slice may connect to more than one data network. So slice 1 is connected to data network 1 and data network 2. Data network 1 may be some URLLC, 2 may be some other service. And also one data network can serve to more than one slices. So that means suppose a data network means a service by say Suzuki. So Suzuki may have network slice taken from Airtel and Jio, or they may have two slices for two different set of services which they may be offering, and so on. So you can see that all these permutation combinations are allowed. Okay, so now look at this picture. So UV1 is now accessing to network slice 1. Any question?
Yes, sir. I have a question, sir.
Yeah.
Say it is correct me if I'm wrong. This user equipment has to decide the what type of how the network has to be sliced, or the slice will be already there and user equipment is going to use that.
Slice will already be there. So slice will not be controlled by user equipment. User equipment is just a communication device connected to a different kind of say to connected to a car, connected to our smartphone, or connected to a smart meter. So that will not decide. Actually, slices are configured by the operator. Now the user equipment, what information it will have is that which slice is allowed to the user equipment.
Okay. No, it is not based on the user's requirement. No?
So based on users requirement only. So suppose I am a company, I am trying to install a smart meter across a particular state, and I am trying to use the 5G service. I'm trying to use the network slice. So what I'll do is that for all my IoT sensors, I'll buy the subscription from one of the operator saying that, okay, it's a smart meter service and a smart meter slice you create for me, or in case you already have, you allow me that. So while provisioning those user equipment into the network, they will be allowed a particular slice which is handling the smart meter. No other slice, say, will be allowed to that particular chip or user device. So whenever they are trying to connect, it will connect to that slice only, no other slice, right?
that be the case, in case in one particular area, uh, some of the slices are not used by anyone, then is it not waste?
That's what I said, that slices are, when we talk about RAN slice, basically area, when we are saying area, we are talking about the coverage from the radio because core is common, right? So,
Yes, sir.
so what I'm trying to configure, I was just explaining that suppose there are two slices. One slice is URLLC, basically for Industry 4.0, and one slice is EMBB, basically for smartphones. Let me take that example. So wherever there is a factory area where Industry 4.0 kind of infrastructure there, and they are using URLLC services in a network. So the radio which is covering that factory area, majority of the frequencies I will be configuring to support only the URLLC slice, and a small chunk of frequency I'll be configuring to support EMBB, because in factory also there will be human. Okay, so it will be best used. If I go to railway station, I have same frequency resource, two frequency resource. So both the frequency resource I'll configure it for EMBB. So that way I will avoid unutilization of the slices. That is what is talked about in release 17.
Thank you, sir. Thank you.
Because URLLC requirement would only be in the factories where things
sir.
are going on. I can give one more example. Suppose I create a corridor from Delhi to Jaipur, a different corridor, and there I roll out 5G services for URLLC. And I know that that corridor is for, I have created only for autonomous car. So all the autonomous car or self-driving car are running on that corridor. So that means when I do RAN slicing, most of the resources of frequency I'll be allocating to URLLC slice for autonomous car and a small part for EMBB, because there will be travelers also who want to use the EMBB part of it. So that way, so based on application, based on use case, I would be configuring the slices. And that's why, this is the way 3GPP has defined in release 17.
Thank you, sir. Thank you.
Am I clear or?
Yes, sir.
Okay. I have also shared the 3GPP specifications from release 15 and release 17 both, so that you can know the difference. Read 15.1 and then, so I have taken from the main specification part of the portion which deals with the slices and given to you on a shared slice. So you can just go through that, gives a better idea. So a UV connects to two network slices served by the same EMF. So one UV can connect to up to 8 slices simultaneously. That's the configuration allowed in 3GPP, that one UV simultaneously can connect to 8 slices. So at a particular time, later on it can have different set of 8 slices, but at a time 8 slices it can connect to. That also means that a particular AMF is handling all those 8 slices. And single AMF will serve the UV. That means if I'm connecting to 8 slices, the same EMF is also common to 8 slices. That means that, and for every slice there will be a separate PDU session. So one PDU session will be using only one slice. There is no question of a PDU session which some resource it is taking from one slice and some from other. So that also means that you will have multiple slices, multiple PDU session in each of the slices. So that's the overall concept of PDU session. So like this, that in slice 1, I have one PDU session. In slice 2, I may have more than PDU session B and C, and slice 3 I can have. So that way I can have 8 slices, and there is a limitation of PDU session also. So there can be maximum of 15 PDU session allowed to a user equipment. Please recall somebody asked me question when I was going through quality of service, that how many PDU sessions are allowed. So if you look at release 15 and release 16, so they have not defined how many PDU session. But when they talked about admission control, so they have also come out with certain numbers like 15 PDU sessions per UE. So that is the limit which they use for admission control. Okay, this we have already talked about. So now there is a concept of registration group, network slice, simultaneous registration group. So this means that when a UE gets registered, okay, it gets registered for a group of slices simultaneously so that it can use the services. It need not authenticate again and again, right? So that is called registration group. So how? So so basically, so UE subscription, during the subscription itself, you know that which all group it can simultaneously register to, right? So UV will be configured about that, or AMF informs during the registration. So both aspects would be there. So just look at this picture. This will make a clear one. Okay. So suppose a UV user equipment, as we had discussed, that have subscribed to certain slices, and those slices are, say, slice 1, slice 2, slice 3, and slice 4. Now there are group, as I said, that there are group 1, group 2, group 3, registration group. I'm talking about registration group. So there can be groups. So what it's shown on the right side is that slice 1 is there in group 2 as well as group 4. Slice 2 is there in group 2 and also in group 5. Slice 3 is there in group 2 and group 6. Slice 4 is in group 6. Suppose I register for group 6. During the registration, I register for group 6. So which all slice I can access? I can access. Can you tell me that if I have registered for group 6, which all slice I am allowed?
4.
3 and
3 and 3 and 4. If I have registered for group 2, then I can access
1,
slice 1, slice 2, 1, 2, and 3. So you have understood. So this is the simultaneous registration of network slices concept. Okay.
May I ask one question, sir?
Yeah, please. Yeah, please.
Not this slide, previous slide. Does slicing have any restriction on our frequency of operation or anything?
No, no, no.
May-
So,
Okay.
so radio part do not have any restriction on the type of slices, etc. The limitation would be in a different way. Let me one thing make you clear. How frequency comes into picture. Suppose I want to have a slice for agriculture, where I have a lot of IoT sensors installed in the agricultural field, right? Now, since agricultural field are large, geographically distributed, I need a very deep coverage, right? I need a deep coverage, and deep coverage I can only achieve on lower frequencies like 400 megahertz, right? So if I'm trying to create a slice of agriculture, then I will definitely be using those spectrum which are on lower side, 400 megahertz, because otherwise I may not be able to cover the entire area. So this is how you have relation with the spectrum or frequency. Is it clear, or shall I give another example?
Okay, sir. Okay. Just I'm correlating RAN with some frequency of operation. So
Yeah.
there is no frequency dependency in slicing.
Frequency dependence is based on application. As I said, for example,
Yeah,
suppose you have autonomous car, where latency is very important. Latency is very important. And better latency I'll be able to get with say 3.5 gigahertz frequency, so that I have a small cell and larger numerology, so that I'll be able to achieve those latency. And there is something called packet data volume, PDB, so that I can achieve only in 3.5 gigahertz. So basically I'll dedicate 3.5 gigahertz for slice related to URLLC on a particular place if required. So this way you have relation with frequency, yes, but as such, those are only to meet those QoS requirement. I mean, there is no technical limitation. Those are use limitation kind of.
Okay, sir. Thank you.
Okay. Okay, now let's talk about one more feature which came in release 17, which is called Slice MBR. Slice MBR. Slice MBR is nothing but maximum bit rate. So basically it's a control. One UV, how much maximum bit rate I should allow in different PDU sessions, because I know that PDU session, there can be multiple PDU session in a slice by user equipment. So how much total bit rate combining all these? So at slice level, I manage the maximum bit rate. So this is to be enforced as part of quality of service. Now comes the concept of RAN slicing. So basically, I have already talked about it, but let's look at through the picture. So it came in release 17. So suppose you have a radio access network, which is supporting, say, frequency 1, frequency 2. So it is possible to configure slice 1 in frequency 1, slice 1 and 2 in frequency 2 of that radio access network, right? And how it is used by the UV. Suppose UV is trying to access the network, that means RAN. So during that, so basically when it does the synchronization process, RAS process, then it knows that at that point of time itself, it should select a particular frequency only. Suppose it is trying to access EMBB slice, so it will be latched to the frequency 1 cell 1, not frequency 2. Frequency 2 is also allowed for EMBB, so 1 or 2. In case of URLLC, it has to connect to this. So, and second is during the reselection, cell reselection. So do you know the cell reselection concept? Cell selection concept is that when a UV is already connected to a radio, it keeps on monitoring signal coming from other G node Bs. And then if the signal is good to other one, then handover takes place. So since now there is a concept of slicing, RAN-based slicing, so it also looks for a particular RAN which all slices are supported, right? So this is slice-based cell reselection concept comes into the picture. So slice-based RAS configuration and slice-based cell reselection comes when we have slicing environment in our network. That is one. The second is something called AS group. AS is nothing but access stratum. So there are group, I think network slice AS group, network slice AS group. So what I'm trying to say here is that on a tracking area basis, tracking area is cluster of G node B. It could be one G node B, it could be multiple G node B. So one tracking area may support, suppose two groups, right? Group 1 and group 2, right? So I was talking about group earlier also. And then every group can support a certain number of network slice. So here what we see is that Group 1 is supporting, say, network slice 4, but group 4 is supporting 1, 2, and 3, network slice 1, 2, and 3. So this will be used for slice-based reselection and slice-based RAS configuration. In the previous diagram, conceptually I explained. In practical, it is the group, right? The way groups are defined, that one group supports 3 slices, other group supports 1 slices. Now, the next concept is, suppose I have now 2 tracking area, multiple tracking area would be there. So what I'm trying to say that one group may be present in multiple tracking area. For example, here, group 4 is in tracking area 1, and this group 4 is also in tracking area 2. Okay. And then one slice can also be in more than one group in different TA. So can you see that which network slice is there in 2 tracking area with different groups?
1, 2, 3, sir.
Yeah.
Yes,
And
same group.
Slice 4.
Four.
right. So this slice 1 is here. Okay, network slice 2 is in NSAG 3 also. Like one slice can be more than one group, but in different TA. So what I'm trying to say, let me explain it again to make it clear. Let me first erase the ink. What I'm saying is that here, if you see slices, suppose slice 1 is in this group, it cannot be in this group in the same TA. Within the TA, one slice is unique to one group. But if you go to other TA, this slice 1 can be in other group. For example, slice 2 has now in group 3 here, not in group 4. Is it clear? And these are all for slice-based reselect.
So one question. So because we are in a TA2, suppose we are having network slice 2 in NSG3 also, and with orange color, and NSGA4 with green color, and network
So
slice
I
2.
think that is wrong. So that will not
Yeah.
be repeated. So
Hmm.
that here it will not be there. So you are right. So you have
Yes.
found out the correct thing. Maybe while making, I have tried to make it myself. So that may be error. Okay. So how these groups are configured onto UV and the network. So first, let's talk about radio access network. So this configuration of group can be done through a O&M terminal. So every G node B, maybe from the central location, this can be configured, or maybe through the script, those things can be configured through a O&M terminal. Or when a RAN is installed and commissioned, at that point of time, AMF can configure it and define those TA-wise groups. So basically, in that case, AMF provides to NSSF, and then second is how UV gets. So basically, AMF to NSSF, and NSSF when UV registers, no. So at that point of time, through the procedure, this goes to the UV. And this can also be already configured in the UV, possible. If it is not, then during the registration process through AMF to NSSF, and through that it can reach to the UV. So UV also knows different groups. So in a particular UV, I can configure up to 32 different groups and its availability in the TA. So when registration takes place, network knows that I am in which TA, and accordingly all nearby TAs are also known by the network. So those configuration parameters are passed on to the UV, and UV keeps it like with it for the purpose of cell reselection and also for initial RAS procedure. So again, this table gives an example of the same, that in group 7, I have these slices. Group 8, I have these slices. And these are available in these TAs. And this is the priority. Initially, priority is to connect to group 1. So many groups are there. So which group to be connected? So group 1 would be the priority here. Here, group 2 would be the priority here. These are configured onto the UV. Okay, so I was explaining about RAN slicing concept, that in case in a factory area, as I was explaining, you have requirement of URLLC. So in this area, what I'll do is that I will define URLLC in say frequency 2, and in frequency 1, I'll define EMBB. Maybe in frequency 2 also I define EMBB, right? But the same spectrum, if I have and I'm deploying at railway station, then both the frequency I have support of EMBB slice only, because I don't need URLLC here. So that's how the RAN slicing concept will happen. Okay, now the next topic which this slide shows is about the interworking with 4G. So if you recall, in 4G also there was a concept called dedicated core network, DCN. Dedicated core network. What was it? For IoT, NB IoT, you might have seen. So for NB IoT, you have a separate core. You are not using the same core of 4G LT which you have for normal customer. So you created a different core, right? As those are identified by a DCN ID. So suppose in 5G, some devices are having massive IoT kind of slice, and it is similar to say NB IoT connection. So when there is a roaming arrangement, suppose it's a moving vehicle where this IoT installed, and you are in a 4G area. So there is in release 17, they have talked about even the roaming in EPS would be possible for that particular slice. For IoT type slice in 5G can work in EPC also. So wherever there are different DCN in 4G present, if it is present, then we can configure it as a roaming both side from 5G to 4G and 4G to 5G. Okay. Now final 2 slides. So for every slice, as we know that it will have a different configurations in terms of quality of service requirement. For this purpose, GSMA has created a standard through their document. This is the document name, wherein they have given a slice template, right? So what happens is this is the function nest, they call it, network slice preparation. It takes general network slice templates and then fill up the value of different parameters and creates a template for a network slice, right? And to make it standard, 3G, GSMA has worked upon this across different network. I'll give you some example. For example, suppose a high performance machine type communication slice is to be created. So there they say ki, okay, availability should be 99.999 kind of a percentage. Then device should be static, like smart meters are static, they are not moving. Then density can be 1,000 devices per square kilometer. It may be a mission critical service and so on. And requirement is of mission critical data and 5QI value, 5G quality of service indicator value supported is 83. So this gives you what should be supported error rate, what should be uh, uh, latency requirement, what should be, all those parameters are defined as part of the 5QI. So these are already template. These are the template which can be used by operators. Other example is massive IoT. So massive IoT, my availability requirement is simple 3.9 only. 5QI is 9, which gives the parameter. And velocity here, I'm talking about very low velocity of 2 km/h, if at all it is there. Or UV density is like higher, right? This is 1,100,000. So these are different template which has been created by GSMA. So with this, I finish my presentation. So I'll open it for any question or any other discussion. Thank you for being with me for such a long time. Yeah,
I want
Arvind. Yeah, please go ahead.
regarding network slicing, sir, is on-demand network